Okay, so I'm gonna make you write down the actual definitions, and here they go. So I'm gonna define them in English first, and then I'm gonna tell you what it means in physics. So Merriam-Webster's dictionary defines dispersion, that I'm gonna call fancy D. Oh, I can't draw D's. As the action or process of distributing things or people over a large area. So if you have a group of people that are together, how do you separate them into a larger area? So think of light, white light, as a group of lights together. How do you make them go dispersed out? And deviation, that we define with these deltas, is the action of departing from an established course or accepted standard. So think of this as a deviation away from the normal. Let's define them now for physics. Deviation is deviation away from the normal. Dispersion is spreading things out. So once we have these things in our heads, now let's talk about the relationship between N and D and delta. Okay, first of all, I want to do relationship between N and D, where N is the refractive index and D is the dispersion. So remember I said that the relationship N is really not constant. It depends on lambda, right? N is a function of lambda. So N relationship between light and the glass that you're using is not simple. So I can say that the relationship between N and lambda, number one, is not simple, because N depends on lambda. So each light experiences a different refractive index. But we have to do something to standardize things. So what we do is we use three indices called NF, ND, and NC, where NF is the blue line produced by hydrogen with lambda equals 486.1 nanometers. We use ND for yellow lines produced by helium, corresponding to lambda of 587.6 nanometers. And NC is the red line produced by hydrogen with lambda equals 656.3 nanometers. And the mean dispersion D is defined as NF minus NC. Okay, so physics also defines what is called and ABBE's number, which is V equals ND minus 1 over NF minus NC. So that's the relationship that you should box and keep handy. Remember, this is not volume. This is the funny looking V. That's for ABBE's number. What does the ABBE's number tell us? This tells us smaller ABBE's number implies larger or higher dispersion. Similarly, larger ABBE's number implies lower dispersion. So I'll give you an example. Flint glass has a smaller ABBE's number, but higher dispersion. So if you were to draw an ABBE's glass, what that would imply, this is very rough picture, right, guys? Red to blue. Okay, recognize this is not correct, right? I did not draw this to scale. This is very, very rough. And then this number will probably be, the number for this, the ABBE's number will be above 55. Whereas crown glass, the same picture will look like this. Red and blue. And the number will be below 50. So the ratio of ND minus 1 divided by NF minus NC. If it's above 55, it will be highly dispersive. If it's below 50, it will not be dispersive. And then there's something called light flint and heavy flint. Let's get started on that.